Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today, we have an episode that delves into a GitHub cache poisoning attack, some GitLab stuff again, Spring4Shell, and a few other topics sprinkled in there. But before we get into any of those more serious topics, we'll lead off with just kind of a funny bug that we don't really have lots of details on or anything. And it's the simplest bug of the episode by far, and it's a HackerOne report on Stripe, which is like a payment platform for those not familiar. Uh, and basically, for whatever reason, this HackerOne report discovered that, or reports that the CSRF token validation was disabled on the Stripe dashboard for a period of time. So it was possible to perform actions on victims' accounts on their behalf because there was just no CSRF protection.
Yeah, and in fairness,
Really
little bit
weird.
limited. You did have to use re-enter your password if you want to actually get money out of Stripe, or what was the other, or using solving a captcha is the other case. So there was a bit of protection, but you could still change the account's email and stuff. I just thought it was one of those weird moments. How would you end up in the case where you just go live with all CSRF token validation just being straight up disabled? How would you introduce that code change?
Yeah, I mean, we like to speculate a lot on the show whenever weird stuff like this happens, trying to think like, how could this have happened? Try to get into the headspace a little bit, but I don't think we could do that with this one. This one's really weird.
Well,
So,
if I had to make a guess, it's probably either this is sitting out in some config, developer was working on a new feature, turned it off, and kind of just did a commit dash a, so just adding all of the files into their commit, forgetting that they even made that change. Really quick code review process, misses the fact that the config changed, and thus it kind of slips through. It can happen, and that is some kind of retesting some of those stupid issues. I mean, if you're going for bounties, might make sense to try some of them rather than just assuming everything's always going to be the same. Um, but yeah, I mean that's just my guess on how something like that could slip through, assuming they have the code review process and such. If they don't
even
have a
that
code
though,
review process, it becomes a lot easier.
even that though, I think is pretty would be pretty insane if it was just like caught up in a commit. But yeah, I guess it's possible. So fair
Yeah,
enough. You were able to do what I thought might be impossible. Try to give a bit of an angle to it that might make it make sense. But
I mean,
yeah,
it's developing is hard. Sometimes you take these shortcuts as a dev as you're working on something you don't want to care about figuring out how to work CSRF, and you disable things and it happens.
yeah, not much to talk about there, like I said, but just something fun to kind
Nice
of
easy
lead into
issue.
it. Yeah. All right, so we'll get into the GitHub cache poisoning attack and GitHub Actions, which is interesting because it's not really somewhere you think of as a vector for cache poisoning attacks, as the author points out in the blog post itself. And it's just based on the idea that workflows can use this cache get action, which will perform a lookup in that branch's cache for a particular asset or whatever, and it's possible for a malicious action or tool or whatever to poison that cache if an entry isn't already present. That is kind of an important part because the way GitHub caching works here is the records are read-only, so once they're created, they can't really be changed. So what the author is pointing out here is a supply chain type attack is possible if a malicious action poisons the cache and can affect some other runs of that workflow on the same branch. There is some cache isolation happening where it's isolated only to that branch, but uh, yeah, it could still be poisoned by some action used by the workflow. There's not much more to it than that. Basically, just calling out this cache feature and how it could be abused. It's questionable as to if this is really a bug. GitHub doesn't really seem to think so. They stated that the cache action works as intended, and this issue is out of scope. Basically, I feel I would tend to agree a little bit with GitHub on this one because I mean the scenario this boils down to is a supply chain attack, and in that case, an attacker already has influence or control over your workflow. Now, I'm not saying this attack would be useless. Um, it could be useful for having like a bit more of a stealthy attack because you could poison the cache with like a malicious action, then make the action not malicious again for if anybody goes to look at it. So it could be useful, but it's a little it's a little bit tricky for GitHub to really fix this issue, because that's just how actions in Git work. So the mitigations that the authors suggest here are just like don't use the cache action. They also recommend cryptographically verifying, assigning and verifying the cache, which I mean, I don't know. If you're using a cache, that feels like it's kind of defeating the purpose. Like usually you use cache to have like quick access times and such, and if you're doing like cryptographic verification, that kind of impacts on that a little bit. But
Well, you are saving, though, even doing crypto verification, you're still saving the time of actually downloading the package again. Because it's going to be cached locally. Like, that is the big hit that you're trying to miss when you do the caching. Rather, I mean, it depends. There are some cases where you do actually cache crypto. I don't know. That does seem like kind of viable in this case, where your big hit is just avoiding the network request. Um, yeah, Amy mentions in chat or in CN, or building things. Yeah, during build, after the builds happen, caching the actual artifact there, so you don't have to go through the whole build process again. But you can have a hash of it, so you know that it's still basically the same thing that you expected to have. There are definitely ways you can work crypto into this. I will say, like, in terms of an attack, I kind of feel like doing pen testing, you end up in like a lot of really random scenarios where it's like you have this weird access to something, and from there, you don't know how to really escalate it. This I feels like one of those cases where it's like I kind of agree with GitHub not fixing it. I mean, they could fix it just by having the caches also be isolated to the actual workflows, which I think would be a fair option here too. But in keeping it across just isolate to the branch seems like a pretty reasonable compromise on that front, especially depending on how the branches are being used. You could have a lot of activity, um, kind of with many workflows, or you might just have like one workflow per branch. So it depends on what that looks like. So I kind of get both cases, but I could imagine, a pen tester just ending up in this random scenario. So that's why, even though the issue isn't um going to be that applicable in a lot of cases, especially with bug bounty, where you don't get to do all of the escalate, or you don't get to do as much escalation. Um, I could imagine this being somewhat useful for a pen tester who just ends up in this really random scenario where they do have access to modify the one workflow, but not the others, and kind of using that to just escalate or get that one little step up into a slightly more privileged workflow.
yeah, I agree. I think this attack has some merits, but the practical implications are going to be super context specific. And that is a valid point with the code signing. I mean, you are avoiding the download times or the building. So if you're dealing with large assets or something, then yeah, it probably makes sense. I will say I wasn't even really aware of the cache get action before this blog post. It kind of brought awareness to it a little bit for me. Granted, I don't do a ton of CI work. Like I have done it for some of the repositories that I manage. We use it for like the tool chain, the open source tool chain for PS4 stuff quite a bit. But I just never really used the cache action or really thought that or really knew that it existed. So it was kind of cool to be made aware of its existence by this blog post. And yeah, it's a cool attack to think about and one that could be useful in some specific circumstances. So
Yeah, I really figured it was one of those things. Just you might end up in this case. It's worth being aware of it as a vector, but and I mean I would love to see this actually happen in the real world, because if somebody pulled off this attack with kind of the constraints we have, it would be a cool attack. So I mean, it's a good find, even if it wasn't fixed or resolved fully by GitHub.
yeah. So staying on the Git side of things, we have a GitLab topic as well. This is coming directly from GitLab's blog, and it's an account takeover bug that affected GitLab Community Edition and Enterprise Edition in 14.7 to 14.9. And I'll let Z take this one away.
Yeah, this one was a little bit weird to dig into. You could get the gist of it right from the title. Static passwords inadvertently set during OmniAuth based registration. basically you could take over accounts because when you use this OmniAuth as the provider for any of their federated logins, so OAuth, SAML, whatever, LDAP, I guess, being the other one they mentioned, using OmniAuth as the provider there, it would set this password. Got to pull the commit link here. 1 second. But the password was kind of what you'd expect, just like almost keyboard mashing, as it would just set. Um, Here we go. It would literally just set a static password. The commit was hidden a little bit, so I just pulled up the code. Basically, when it's creating the password in this OAuth user RB, oh, I've lost it again. There we go. Basically, it would literally just set the password over to the test default, and big part of this hash was introducing this test default constant, which was like 123 QWE, like very much like that keyboard finger rule, and then it would just pad it with zeros for the rest of the password length they need to actually get. The idea of this whole command, there's actually quite a few changes in this commit. Was that they had I went and dug up the issue on it. Somebody there just had a SaaS tooling that was complaining about all of these weak passwords because the old password was I think 1234567 8. Like it was this really weak password, so the SaaS tooling was like, hey, you've got a weak password. They wanted to fix that by using something that looked a little bit more secure. And so a lot of these changes are just changing this password in the test code. A lot of this is just in test code, creating accounts or testing certain cases where he's like, not the password or with the right password, creating the alerts, doing that. So this is a lot of just test code being done. But that one file, and this is where questions coming up in chat from Amy and from P512, what code review or how did this get past code review? I was wondering the same thing, and it feels like what really happened here is there's so much to this commit. There's 34 changed files, and it's just the 2 lines in that user Ruby file that introduced vulnerability. The rest of these are changing it just for test cases. So it's using this test password and just using something a little bit more secure as a test password. And then in the middle there, it slipped through. There was, and I might have the link here, but this did actually pass a code review. So my feeling is that would have made its way through because you kind of look at this at a glance, everything kind of looks okay as you spot check a lot of these. It's being like, okay, just setting this password for these test cases using this, and they explain why. And that one just slips through. That's all I can really think of is the one commit just slips through as, not quite paying enough attention to the impact of that one versus everywhere else where they're replacing auth hash password with this default one. And so by setting that password, basically anybody can log in with that. This was only for a somewhat brief period of time, measured in, just a handful of weeks, because this commit was introduced about 2 months ago. So it wasn't there like for an insanely long time, but it was there long enough. And GitLab did have several users reset their passwords because of this when they fixed it. I don't know. My only guess on how it slips through is the fact that, it's kind of in the middle of a lot. There are some suspicions about whether or not this was an intentional thing because the person who committed this basically not been active since.
I was about to say, like, if I slip on my tinfoil hat and think, how would I introduce a backdoor? I feel like this would be the way to do it.
I
Bury
mean,
it
you
inside of a
slip it
commit
in.
and try to make an excusable, like, oh, we were just trying to change the test code and we accidentally added it in this one additional file and it slipped through. Like, I don't know if there. I'm not saying it is, but
Okay,
if you were
so
gonna do that, then that would be
I'm
a way to do it.
I'm going to walk back a statement I just made, being that they went kind of inactive. Um, or perhaps so I had read that elsewhere. Okay, sorry, I see where it's coming from. I had clicked the wrong name and was like, no, no, they're definitely still active, but I was looking at the wrong person. It looks like. Um, yeah, I mean, you can have that. There's no real proof of that, but you are right. Like, if you were trying to commit something that slips through, you would do it in the mix of all of this.
Yeah, it's kind of the perfect storm that allowed this issue to slip through, it seems like. So,
Yeah, and also out of chat, it mentions they need a better way to separate the test code from the prod code in their code review. In fairness, I mean, one of the things here is almost all of these commits do take place either under like the spec or EE spec directory. So like that makes it clear. And then you just have these couple commits where they're doing it under like the core GitLab OAuth file, or use the user RB under that and password.rb. So I mean, like you do have the directory kind of splitting there, where it does make clear that this has the wider impact and thus should be. I think some people brought up GitLab's code ownership aspect should have been able to, I guess, get more eyes on it. Yeah, there are definitely some questions on this one. I do think it's a little bit suspicious that this was introduced in this way. I could imagine a scenario where, this isn't an intentional thing. Um, but at the same time, like, I would agree with anybody that thinks it is a suspicious thing, especially just the route that they went to introduce it, like using a function for the test password rather than actually hard coding the password. I don't know, it just makes it feel a little bit more obscured when they do it that way. Like, that makes sense in the sense of having a password that you don't need to update when you want it to be longer, when, the length requirements change. So, like, you get that, but I don't know. I mean, it feels suspicious. It's been fixed. It's a crazy issue to just have introduced there. Like, hard-coded passwords is not really an issue you expect to see on something like GitLab. But I mean, it's still out there, so it could happen. Yeah, I don't know. I mean, this one is just all the other changes make sense, but for really the one where they change that file outside of everything else. So I have my suspicions, but obviously there's no evidence of malintent or of non-malicious intent, so I can't really put blame anywhere on it.
can't say one or the other. It is kind of bad all around, though. Like, either it was intentional and it was slipped through, or the code review was just really bad and failed to catch that case. But you know, like you said, it happens, and yeah, can't really say one way or the other.
Yeah, I mean, things slip through code review. I don't, as much as I'd love to just be able to harp on anybody that misses really obvious issues in code review, we're all human. We all miss issues.
Okay, so like that's
So
fair in general. I agree with that sentiment, but in this case where it is so glaringly obvious, like all you'd have to do is look at the file name that's being changed and see that it's not the test code like the other files that are being committed. It seems like really hard to be charitable there.
there are
I don't
ways,
know.
but it's really
Maybe
easy
that's
when
just
we're
me.
looking at it and we know it's malicious.
Yeah, the
To
hindsight
point that
2020
out.
thing.
Yeah.
Yeah.
It's easy in that case. I don't know. I get where you can miss. I've missed things in code reviews myself, so I'm not eager to also toss blame onto myself. So I'll at least try and defend developers doing it. Like, yes, they definitely missed it, but it's really more of a question of taking it and going back. How was it missed, and how do you prevent it from happening, rather than just putting the blame on the reviewer? It's just how do you and go with that. Rudimal mentions maybe keep test stuff in a separate repository. Bit of a pain though. Yeah, so that probably comes down to how GitLab's kind of organized here. that could help. Although in this case, they did also have a legitimate change into the more production area that was in test code. And on the other hand, you sometimes want to keep your test close to the code, so you change the code, you change the test, and making it convenient to change your test and keep your tests up to date. So you can kind of go both ways. Like in this case, sure, that might have helped. In another case, maybe not. In this case, they did have a legitimate change there, so like they would have needed to change both anyhow. Although having just the isolated like 2 commits would have made this a lot more obvious. Well, I'm saying 2 commits. I haven't looked through absolutely everything to see that. Looks like there's maybe three that come out of the live folder. Yeah, I don't know. I don't know enough about GitLab's internals to really make a suggestion on that side. It would help to at least know, like, does this have production impacts versus the test impacts? Like, having that sort of thing. That is something they could introduce or find some way of introducing, but yeah, I don't really have more to say on that.
All right, so we'll jump into our headline topic of the episode, which is Spring4Shell and a security analysis of it, plus another vulnerability that was discovered around the same time. So this is a post by Lunasec, which has like a general overview of it. I'll let Z get into the Spring4Shell bug, and then we'll get into the other bug, which dropped around the same time.
Yeah, so Spring4Shell, I'm sure most of us heard of it, of course. Also, Log4Shell happened not that long ago. The naming kind of relates. I don't know. Some people were also calling this SpringShell. I kind of like the Spring4Shell, but whatever. Named Vaughn, so whatever happens. This was dropped basically via a tweet by a Chinese researcher. Dropped the tweet with this as an ODE, and then, or I believe it was as an ODE. Definitely, I don't believe it was patched yet. And then deleted the tweet, of course, but everybody had already kind of jumped on it and was looking into it. The core problem in this one kind of feels to me like just when you have code that tries to be too generic or like handling all the different possibilities, all the different scenarios, and trying not to put any constraints on it is kind of where this one comes out of. So in the Spring framework, you've got, like, they have some sample code here where you can basically write like a really simple class. If you're looking into this a little bit, they'll call them POJO classes or plain old Java objects. Simple idea being you write a class which, doesn't inherit from anything, isn't complicated. It's just like you've got your fields and you've got the getter and setter methods to whatever fields you create. And then with Spring, you can go and say, create a controller and map your model, which is this simple class, to that controller and be like, basically what Spring will do is allow you then through like the post or through the get URL parameters, you can set these different, whatever variables have, getters or setters. It'll basically just like you set those via the URL parameters or via like a post field. Basically, just making it convenient to change those values, set up handling for certain arguments by just saying, I have a class that does this, and it will magically figure out how to map your URL queries and parse them. So then you just write your code assuming everything parsed correctly. And they try and handle this in a very generic way. And what ends up happening is, well, yes, with this greeting class that they have as an example here, they have this private long ID, which is just this ID field and a getter and a setter for it. And so when they go through figuring out what fields you can set through the URL parameters, you, of course, can set the ID, which makes complete sense. What's unexpected there is the introspection that they use, and they're just using, it's come through Bean, so it's like Bean introspection or some class like that. Java Beans introspection is the class which does this. It also returns a class. And that's because every object in Java by default is going to basically have this get class method in it, which, I mean, that just comes because every object inherits from the class or object, like this base class. It's either class or object class. It's been a while since I've worked at that level in Java. But it just provides a number of methods, one of those being get class. So it sees like, hey, there's a getter for this class field, and therefore you can actually set, well, you can't set the class, but it'll return class as one of the properties that can come through. And then you can just use dot notation, so class dot something else, to access further fields underneath it. So go from class to the class loader. So back in 2010, this very same attack actually happened. I'll pull that up here. And they use this class person as their example. But they can come up with the property class, and then they can access the class loader. And what they did is they just did basically the class and class loader, then URLs, and we're setting a value on that. So in their post there, it's class.classloader.url 0 equals jar and HTTP path, which would literally just set one of the class loader paths, so where it looks for new classes, as a remote URL and load a jar. Now that was not the case now. You can't use a remote URL like that. But this was back in 2010, exact same attack, exact same issue. It was the fact that this class was included in the introspection, so then you could access it. And so this got patched. And that patch would basically just check if the class equals, well, bean class. If it's the basic class, where is bean class set? I might need to pull up Xcode. Either way, like, it's basically just checking, is this is the class that they're looking at or iterating over, trying to get, is that equal to class.class? And if the property you're trying to access is class loader, it rejects. So you can't access class loader anymore. That was the patch back in, was this done in 2010 also? Yes, that was still done in 2010. And then 2013, they added another patch which also blocked the protection domain field. Exactly the same deal. I don't actually know what the attack was there, what could be changed under that, but in this case, back in 2010, they blocked class loader, and then they blocked this protection domain field. And now, for this new, 2022 attack, they had to block module. Because with Java 9, I believe, introduces the concept of modules. So now you could basically get access to that class loader again by going class.module.classloader. So now you're in this module class rather than the class, or the base class, basically. Rather than being in there, now you're in this module class, which is not the class.class. It's not the class. Lots of classes for this.
I'm dying over here.
I saw Spectre in chat said, we heard you like classes, so we gave you a class for your class that you can use in your class.
Yeah, it's just so hard to cover this topic. Because
I apologize for the listeners here. But what you end up with is Java 9 introduced modules, which introduced a new way of getting access to that class loader. Of course, like I said, you can't change the URL anymore. That doesn't work. You can't just have Java load up the remote URLs anymore. But what you can do, or what the main attack that we saw dropped did, was it basically went after class module, class loader, and then under that, it kept kind of exploring other classes that you'd get under that, and they found resource, context, parent, pipeline first. What is that? When you're running this under Tomcats, when you're running just a Spring application under Tomcat, that starts dealing with the logging information. And so the attack there would basically just set the pattern for the log to be JSP file, effectively just injecting Java shell. Then they change the suffix for the file to .jsp, say they want to write into the web app root, prefix as the name being a shell.something, and then no date format. So basically they would change these contents so that the log that was written would end up being this Java code for the JSP file, and it would write a .jsp file into the web root because they changed all of the core logging information. So it's a very kind of data-focused attack. So there most likely other ways of exploiting this beyond just that. Just other things you can do through once you have access to that class loader, but it is going to be context specific, and they've just called out this one particular instance of it. The patch was a little bit more complete this time. They didn't just block module now, like I kind of hinted at. That's what they needed to do. They did do a little bit more, where they basically block access on the class, on that core class, as you can only access the name through the core class. And then they did some other checks to see about accessing, trying to access class loader or protection domain just altogether from any sort of class. So you can't access any properties underneath there. So they've done a little bit more here, but it is still kind of going that block listing route. So, there's still kind of a chance here of something more. And all of this really comes down to what they really need to do to fix this is at least, I mean, the introspection just kind of gets a little bit hard in general because you can have a lot of really random objects start appearing if you know all of the source. But it's just not having the Java Bean introspection, not having that actually iterate into the base class. And you can provide that rather than providing the class for it to do the introspection on. You can also provide a end to class, so it won't go into it or it won't go beyond that point. And that would just stop all of that altogether. It seems they do want to provide, though, this access to the class name at least. So kind of makes sense for that to be there. Which, I mean, makes sense when you're doing introspection. You do kind of want to be able to resolve the class name. But it does seem like they could use the introspection class a little bit better. But also not wanting to break old code. So it is a bit of a challenge here. They've definitely done a bit more of a complete patch here in terms of trying to prevent access, at least to the class loader and protection domain classes completely.
Like you said, though, they kind of dug a hole with the way that they designed this. So that's kind of why they're in this weird area where they have to do this like blacklisting type patching, which isn't really great, as it's been shown that it's been bypassed multiple times before. But they kind of don't really have any other choice unless they redesign it. And if they do that, then they break compatibility with older code. So yeah, it's just kind of a weird spot to be in.
Yeah.
So yeah, I mean, at least for this issue, the patch seems sufficient. Like Z said, I believe all the public POCs that are out, at least the ones that I've seen so far, do leverage the Tomcat logging capability in order to get RCE. There are probably other routes to do it, but I'm guessing all the POCs are just using Tomcat because it is a popular piece of software that could be used realistically with Spring as well, and it's just like pretty easy to do, right? You're just setting like the pathing and the pattern for the log to write a shell. So
Yeah, being
yeah,
data oriented, like it does make it an extra challenge because you need to know exactly what the data structure is for your target. Um, so yeah, Tomcat is basically the most popular option here. So that's kind of what they're going at, but it's just one. To me, this feels like one of those cases. One, the block listing is a bad option in general. But two, just trying to handle all the potential cases rather than having some restrictions on it.
yeah. And I'll also get into the other issue here. This I'm going to go to Cyber Kendra's blog for. The second vuln has to do with Spring Cloud function and the fact that it can receive Spring expression language or or spell expressions in this HTTP header. I think it's spring.cloud.function.routing expression. So as you can guess with the name, it would use it when it was routing requests and deriving function names to perform a lookup. And I believe the vulnerability here is the fact that they're doing that evaluation of the expression inside of a simple evaluation context, which has the I had to go into the docs a little bit to look to see this, but apparently in standard evaluation context it can resolve like properties, methods, and fields and stuff like that. So the patch for this was to track if it was using an expression from the header, and if so, it would evaluate it in the header evaluation context, which I think is more sandboxed and locked down, so you can't like evaluate the methods and stuff like that. So yeah, it just seems to be like accidentally using the wrong context. This one is a little bit uh it's quite a bit different from the first issue, but it was dropped around the same time, so there are a lot of like news articles and whatever that are calling them out as like the same thing. But they are like different bugs. Although I believe they were both. Actually, no. I was gonna say this one I think was also kind of opened up by Java 9, but I can't find anything suggesting that. So,
Yeah,
um,
that aspect I'm not too sure about.
yeah, I'm just
But
taking a quick look, but I don't see anything mentioning it. So yeah, I'll walk that back a little bit.
as soon as people kind of heard about the Spring O Day, I mean, the tweet was deleted, so nobody really had all the clean information. It's like you start looking at things, it's like there's an issue, so you start spotting more issues that you might have overlooked otherwise. And I think this one's kind of found because of that.
Yeah, exactly. Um, It would be interesting to see if there's more issues that come out of these Spring Cloud functions, because whenever you're talking about an expression language like this, where it's getting parsed and evaluated in different ways, and it's being used in something as critical as routing in this instance, I could see there being like more bugs being discovered off the back of this bug. You know, just saying like, oh wow, this one was pretty easy. Let's do some variant analysis and see if this exists anywhere else, or if there's something kind of similar. So yeah,
Well,
it'll be interesting to see if more comes out that's similar to this issue.
yeah, on that note, actually, I will call out that back in 2010, um, on that post, so this is going back to the first Java Spring one. Um, he calls out like there are a lot of classes, and this was back in he used Google's code search back then. But there are a lot of classes that use the introspector get bean info and only provided that first class rather than also providing it a stop class. So there's a lot of code that will do this. So I mean, it's something to be aware of just with Spring in general. Well, I guess not Spring, but with Java code in general that might be using the beans, which again, pretty commonplace. That do this introspection. There are probably others that have some security implications beyond just Spring. Spring's the most popular, but this sort of issue and misuse of get bean info might result in I would imagine it'll result in other vulnerabilities. Whether or not we cover them or they get big coverage, I don't know, but it seems like one of those really fundamental issues that can exist in a lot of places.
All right, so we'll get into our last exploit focused topic here, which is a Sonar blog post looking at PHP's PEAR, which is the decades old package manager or PHP extension and application repository. In the blog post, they detail two vulnerabilities they found accessible on PEAR Web, which is exclusive to like verified developers, which is important to call out. Because it's used for like publishing packages and managing packages and such. And you have to submit an email or whatever and get verified before you
Um,
can get access to
I
it.
I will really quickly say for anybody doing the spot the vault, a little bit of a spoiler warning here because the issue comes from this post.
Yeah, fair call out. So, yeah, they detail two bugs they found. One was a 0 day, the other was an end day that was chainable with the first bug. The first bug allowed them to gain access to a developer account on PairWeb to the password reset mechanism due to weak PRNG when generating password reset links. Basically, when generating the reset token, they'd simply take an empty rand number between 4 and 13, the user, the time, and the new password. And like if an attacker knows a user and obviously they can set the new password to use, the only secrets, for lack of a better word, in the hash are the empty rand, which has a pitiful entropy of 9 numbers, and the time, which is easily guessable as it's epoch and it's in seconds in PHP. And you can even get the like current time in epoch of the server through the date header in the HTTP server. So you can calculate the drift and pretty easily guess what the time is going to be when that hash is calculated. So because of that, Sonar observed that the password reset tokens could typically be brute forced in less than 50 tries, which they wrote a script for to do really quickly. So just a really old code for generating the reset token that is not at all like secure. There's no secure randomness going on here. It's very easy to brute force and iterate.
Yeah,
The
I
second
mean,
bug. Oh, go ahead.
this one, yeah, I do want to jump in briefly. MT ran like isn't the worst choice for a PRNG. It's not cryptographically secure, but it's not like the default RAND either. It is at least a little bit better depending on how you're using it, but having it between 4 and 13, like one, who thought of those like that is the range? That's
It's so
literally just
strange.
saying like choose a number between it's inclusive, but 4 and 13, like why those numbers in the
It's
first place?
so
Like,
random.
and yeah, it's just such a weak amount. Like if there was a little bit more there, plus some rate limiting on the attempts, suddenly this isn't as exploitable. I will also call out, and I don't know if this is the case, but I noticed that the way this reset password seems to work is you've got the user in the past one, so of course the username coming in, and the new passwords that you want to use. Um, Presumably, that pass one, pass two, like enter the password twice and client side validates it, but the server isn't bothering with that validation. Not really a security issue that doesn't do that check though. But what stands out to me is one, their use of MD5, and they store this, the lost password and the requested password they store in there, or no, sorry, the new password they store is just the MD5 of pass one. This also seems to me like they're storing passwords in MD5. Which
That's a little
I
worrying
mean,
too.
unless so they might in the actual code once they go through this lost password flow, when they actually insert the new password to the user, they might then be hashing the MD5 more securely. Which would at least be a better approach there. But like they no longer have the original password, so they're doing something with that MD5. So that's a little bit concerning to me. And something else that kind of stood out, but the core issue is just how predictable the token is for the new password. When you look at the code, 4 through 13 is not sufficient randomness.
Yeah, like you said, 4 and 13 are just weird numbers to choose. And jumping back a bit, when I was saying that's so random, I meant like just choosing those numbers. It's definitely not very random. That's the problem.
Yeah, I
So,
mean it is. It's weird, and even so in fairness, this code was introduced in 2008. So the use of MD5 isn't that crazy. It was still used pretty often back then. I remember calling this out on engagements back in like 2012, the use of MD5. So I mean, old code kind of using it just as like the default hash because that's what it's built right into PHP. It's super easy to use. Why not? Um, So part of this is a legacy aspect. It's not like they wrote this last year, which I think would be a little bit more egregious, but it is still pretty egregious code. But it's a different era these days where we're more aware of a lot of security issues, I guess.
so I was about to get into this a little bit actually because as far as I'm aware, like I haven't written PHP in a couple years, but the recommended way of doing like password hashing and verification was to use the built-in password verify and password hash functions, which I think use like bcrypt or something under the hood, though I don't remember
It
exactly
could
how that
use
works.
different algorithms. Default is with bcrypt, I believe, but it also supports
Okay,
Argon.
yeah. So I was like, was this what were these functions around back when this code was written?
No,
Because
oh,
okay,
they're
because
new. Yeah, it actually says here, because I pulled up the docs, PHP 5.5. 2008 was still like PHP 2 or 3. I'm not even sure if
okay.
5 was out yet. 5 might have just been out, definitely not 5.5. But no, these are far newer than that. People were still using MD5 for passwords, and it wasn't really this widely known issue just yet.
Yeah, I knew password hash and verify were somewhat newer, but I didn't remember like because I remember them being introduced around like PHP 5, but I don't even remember how old PHP 5 is because
I
I
mean,
just
7 and 8 are
haven't
the
written in so
current
long.
ones. And I think nine's already out. Maybe no, nine isn't. IAPR mentioned in chat. Bcrypt has a length limit though. Yes, Bcrypt. It's like is it like 128 character limit? There is a limit at the end where it does truncation with bcrypt. That said, bcrypt is still fairly strong despite the fact that you're limited to a password of less than like 100 and however many characters. I don't think it's quite a nice number like 128. It is something a little bit weird there. Current recommendation, I would push people towards Argon, but bcrypt is still going to be fairly secure. It's because what you want with these passwords, MD5 is a problem because it's a really fast crypto hash, and because of the collisions that were discovered, like you can easily also cause collisions with it. So plenty of things can hash to the same issue or to the same hash. What you want with the password, though, is you don't necessarily want that same speed. You want it to be a little bit slower, so when somebody's trying to brute force it, they're not able to get through billions in a second. That's where bcrypt using blowfish, it's designed to be somewhat slow. And so, in more ideal use case, Argon improves that a little bit more by introducing memory. I believe it'll introduce a memory requirement, just requiring more memory to also calculate, so then it's harder to do it on like an ASIC or something because you lack something memory. It just increases the computational power and starts requiring more than just CPU time. Um, yeah, I figured I'd touch on that, but I wouldn't see a problem with somebody using bcrypt despite the password issue. I don't know. I mean, I get why somebody would be worried about that when they don't realize it's happening. When it just kind of silently truncates like 100 and some. Although IAPR is mentioning it was part of Hack the Box challenge. So sorry, let me just read the chat. Okay, I see. IAPR calls out an attack where you're using bcrypt as more like or where you're using bcrypt or this password hash as more of a signature. Yeah, it's not the right use case for that. Um, bcrypt is more of the password or key derivation function rather than actually being used as or I guess bcrypt. They call bcrypt key derivation. I would say it does feel like, especially using password hashes you're calling out specifically, feels like the wrong use case to use that as more like a signature.
Yeah, that's just misusing it, I think. That's
But
I don't think that's really fair to call out on password hash itself. Although
but
the fact that
the
it doesn't error or anything is kind of a problem too,
yeah,
but
that's a
that's a different
PHP thing.
discussion.
But the
Yeah.
issue there being like because you'll have such a long thing, but it only hashes the first bit of it. Um, you end up with a hash that only you can change everything after it, so it's not properly signing it. Yeah, that is a misuse of it. I can understand why somebody might do that, not really being aware of it. It is a misuse of it. I like bcrypt on its own, I don't think is an issue. That is a really interesting vulnerability though. I've not run across that one. Although we did cover the other one where it only one of the spot the vulns where it only hashed the first bit based on user provided information. So that's actually a kind of cool attack. I've never seen the code written that way. It is worth being aware of, but for passwords, I don't think it's as much of an issue. Um, and that kind of got sidetracked quite a bit from the original Vaughn.
A little bit, yeah. But we'll jump back to it now, and we'll get into the second vulnerability that was made accessible after gaining access to the developer panel. And it was a bug in archive tar, which PEAR uses. Unfortunately, PEAR uses an older version of archive tar, being 1.4.7, while the latest at the time was 1.4.14. And NDAY, labeled as CVE 2020 36193, was discovered that affected that version, and it was basically the symlink bug that we've seen many times before, where having a symlink in the archive would get followed when extracting it, and it could end up extracting files outside of the intended directory. PEAR used archive tar in a cron job context. So when they would extract package contents from all the packages that they had into a temporary directory to process them with PHP documenter, they would do that extraction. So when you got access to a developer account, you could upload a malicious package which had a symlink to a file that was accessible in the public directory and get like a web shell extracted and get code execution on the server, which could be used to gain persistence. So that even if that first bug was patched and you lost access to a developer account, you still had the persistence aspect there. There was also some fun patch shenanigans going on with this topic. The PEAR maintainers tried to patch the first bug with generating the bad reset tokens, and to do that, instead of doing this weird concatenation with like the username and the new password and this random number between 4 and 13, they just decided to use OpenSSL to generate a random 16-byte string and pass that to MD5 to use as a token, which was, is a better solution. The problem was that they stored that random string in the random bytes variable, but then they used rand bytes in the MD5 call, which is an unset variable. So they were essentially MD5ing null for the password reset token. So they tried to patch it and use a better token generation, and they ended up making it worse for a period of time. They
Just
did
for a little
eventually go back
while.
and fix that, but
Yeah,
that's
it's a
pretty
funny
insane that
issue.
that patch landed.
It's one of this is just such a classic PHP issue though, because PHP is one of those languages, it just keeps chugging. It just keeps working and working until it just can't figure out a way to keep going. Like, oh, your variable doesn't exist. Let me make that for you. And just give it the default value. Like that's such a classic PHP thing that it kind of fits that it happened here. Yeah, I mean, if you had any sort of, you can kind of have a similar thing with like JavaScript if you don't use strict. Um, so like it's kind of a scripting language thing that lets you use that just kind of creates variables when you use them rather than needing the declaration. But yeah, I mean, it's especially in such a short bit of code from random bytes to rand bytes. I have to imagine the developer probably originally wrote it with rand bytes and it was like, well, let's use a bare variable name and only changed one of them. Or, well, I guess changed two of them. That would be my guess on how it could have been introduced, but yeah, it's all
Pretty
kind of a
brutal
funny issue.
patch. Yeah, I think the patch was funnier than the original bug
Yeah.
by a good margin. So, yeah, they also did fix the other issue with the archive tar. Um, they just upgraded that version to patch the other bugs since that was just an end day. But yeah, an interesting chain of issues that could have led to supply chain type attacks, which we're seeing more and more how impactful those can be as time goes on. All right, so our last topic doesn't really focus on a particular vulnerability or exploit, but rather goes into a hypothetical to talk about chaining small vulnerabilities that people don't really think about or dismiss as out of scope, such as like lack of rate limiting or brute force protection combined with no password policy enforcement. Another example they give is image caching in the context of something like a chat, where one user might send an image, then delete it, expecting that, or delete their message, expecting that that image is no longer readable, but it's still cached on the server and accessible with some effort. So, just calling out kind of these smaller issues, maybe to keep them in mind. Now, we figured we'd maybe use this topic as a bit of a launch point to talk about these kinds of issues because some of the issues talked about in here uh, are in the category that we typically throw into like the beg bounty category of just BS issues that don't really have real world impact. But this blog post is challenging that assertion a little bit. And Z, I think you have some thoughts on this that I'll let you get into.
Yeah, I kind of want to call this post out. So the two issues, the first one that they do call out here is like their examples. And to be clear, the name of this post is finding bugs that don't exist. Basically, like looking for those bugs where it's an issue, but it doesn't fall into those named categories. Like it's not cross-site scripting or code execution, SQL injection. It's nothing like that. It's an issue though, and kind of thinking about things in that way. Thinking about what type issues can come up that maybe uh maybe have a security implication but aren't one of these named vulns. And so they kind of go through a few details there. So the first one was usually like being able to do username enumeration isn't that useful. And then if you have a weak password policy, well, now you can also brute force the login weak password. That I don't feel like it's a very good vuln in general because it still relies on users having a weak password. But more where I want to take this one is how I would approach like when you find something that doesn't quite match what you would expect, doesn't match your intuition, but you're not sure if it's an issue. I just figured I'd call out kind of three questions that I tend to ask. ask myself when it comes down to do you report this or how do you report it. So to be clear, I don't do a lot of bug bounties. I've mostly worked on the consulting side, doing engagements where my reports, I would lean more towards reporting even kind of more minor issues. I maybe make it an observation like this thing happened rather than trying to call it as like some crazy vuln. But I had a lot more flexibility in terms of reporting lower risk things because I just give them the information and then they can decide to ignore it or not deal with it. But I've at least let them know what the risk is there and how small or big it is. Um, but I would kind of use three questions. One being, what could the attacker do with the issue? So looking at like what type of requirements there were, what the attacker gained. So that's like if you have code execution, but it requires you edit a file that the user already has, and then run the program using it or something, like you already have access as the user, you're not really gaining much to code execution. So is there a reasonable chance that somebody could modify that file as the user and have all of that access? Like, going from user to user code execution, same user to same user, it's not worth much of an issue. It's maybe worth observing that it can happen, but like it's not as much of a security issue. And the other two questions, what did the developers do wrong? Were they following the best practices? And sometimes I see issues, especially on HackerOne, I'll see people reporting bugs that's like don't quite make sense to them, but like the developers are doing everything right. Like there's just like certain things that are either accepted risks or just kind of commonplace enough that's like, yes, in theory, like you could have this like some obscure man in the middle attack or something. It's like, yes, they can do this. I think one that I've seen like this is sending passwords in plain text, even though it's over HTTPS, but like when you log in, you send a password that isn't hashed, and they're thinking like, oh, passwords always need to be hashed before you send them or do things. Like it's kind of an accepted risk that if somebody can read the HTTPS, they can read those passwords, they can tamper, they can do whatever. So it's encrypted in transit, and then hashing happens on the server side rather than being vulnerable to more of a pass the hash style attack. So things like that. So just what did the devs do wrong? If you can't point out what the best practice is, probably shouldn't also report on the vulnerability until you at least know what they should be doing. So that comes into the third question is how would you even fix it? What can you do to fix the issue? Going back to that password once, like there aren't a lot of good ways to fix that. Um there are actually a couple alternative options there, but not well studied, I'll put it that way. So yeah, kind of just coming down to having those three questions: what can an attacker actually do? What did the devs do wrong? And then how can it be fixed? So the second issue that they talk about, Spectre said that might still be cached on the server, but I think their issue here is actually like you share an image, say on WhatsApp, and in Rudimal mentions if they could man the middle HTTPS, they could steal the session. Yeah, that's kind of the other thing. Is the developers didn't really do anything wrong. It's an accepted risk because you've got all these other attack surfaces. One isn't really all that much of an issue. Um, the browser issue here that they call out is you share an image like on WhatsApp, you delete it, you expect that the other person wouldn't be able to see it anymore, but it's still present. Even though the message is deleted, their system cache might have still had it rather than the server. Maybe it is server cache too, but at least the system cache might still have it so they can still access the message. And in that case, like what's the fix? What do you recommend? How do you basically bust the cache there on like a user side? Like that's something the browser does this thing, but the developers, so in some cases if it's over HTTP, you could have like a no cache header. Like there are things that could be done there, but being aware of exactly what to do, I think helps you kind of figure out, is this a valid report or not? Is just knowing what the fix would be and is the fix reasonable? So yeah, I kind of saw this more as a launch point to dive into like those three questions that I tend to ask to kind of figure out how valuable is this bug and is it worth reporting?
Yeah, you can kind of go either way with that second scenario that they point out. Sorry
Yeah,
about
we
that.
talked
You
about
can kind of go
one.
either way with like a server cache or a client cache. The client cache is a lot more difficult to fix than the server cache problem. But yeah, sorry, go ahead. You were going to point out an example.
Oh, yeah, I was just going to call. We talked about, I don't remember the exact details, but we talked about that Slack issue a while back that had to do, I think it had to do with caching. Something getting cached. Maybe I'm completely mistaken there. But I'm at least kind of reminded of it now. Do you remember the one that I'm talking about? I know I haven't given much
I
info.
I think I do, but yeah, I don't really remember specifics either. But
Yeah,
yeah,
I
I mean,
guess it
it is
doesn't
an
matter.
interesting problem to think about when you're talking about caching. Like, it is a problem that's opened up. Like you said, though, it's one of those things where, like, how do you fix it? You're not really, like, what are you
The
just going to
cache
expect the
headers, you
browser to,
can
like, yeah,
tell it
you can
not
do
to
some stuff
cache.
with cache
So
headers, but
HTTP can do it. But that still wouldn't necessarily solve some other cases where it just gets cached because it was a recent request and not really respecting those headers. Like there are cases where they can't do anything. So thinking through that, I think it's always important to suggest a fix when you make. I mean, you can't always do it, especially with bug bounties where you don't have a lot of knowledge of the code, but at least knowing like conceptually how you would fix an issue, I think can eliminate a lot of those false positives where it's like this just isn't an issue. So yeah, I guess I'd leave it there.
yeah, I mean, those are fair questions to call out, and probably a good rule of thumb generally when reporting issues. So, um, yeah, I think that was fair to bring up. But yeah, unless you have anything else to add on the NZ, I guess we'll go ahead and wrap up the show.
Um, Not a formal shout out. I think we'll do it for tomorrow's, but um, worth at least mentioning. Black Hat IL happened a little while ago. Their videos are out now. Yeah, you can find them on their YouTube channel. So there were some interesting talks there. Probably more for a binary episode, but I at least shout it out quickly on this episode too.
All right, cool. So that's all the topics that we have for today. Thank you, everyone who tuned in. The VOD will be up on YouTube and Spotify and other platforms tomorrow, and will be accessible on Twitch immediately, of course. Remember to check out our Discord or follow us on Twitter. Links for those are on our site or in the chat. Other than that, though, we'll see you tomorrow for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.